Hello and welcome to my channel. My name is Ashish Mahamuni. In this video, we are going to discuss about Quarkus, Java's latest cloud native framework for building web apps. It is supposed that it is going to give tough competition to Spring Boot. It has already created some traction in the industry among the developers community. So what is Quarkus? For those who are not aware yet, let's look at it. So traditional Java stacks were engineered for monolithic applications with long startup times and large memory requirements in a world where the cloud containers Kubernetes did not exist. Java frameworks needed to evolve to meet the need of this world. Quarkus is a modern Kubernetes native Java-based framework designed for building cloud native applications. It's an open source project that aims to optimize Java for serverless microservices and cloud environments. Quarkus provides a small memory and disk footprint, extremely fast startup times, and efficient use of resources. It achieves these characteristics through a combination of technologies like GraalVM, containerization, and innovative development model. So we will see what are the features of Quarkus. So as we discuss superior performance, Quarkus is known for its incredible fast startup times and low memory usage, making it well suited for serverless and microservice architecture. Container first philosophy makes Quarkus modern. Quarkus is built with containers in mind. It can be compiled to native executables using GraalVM, resulting in lightweight and efficient Docker images. Developer productivity is also one of the feature where Quarkus promotes. It's a very developer friendly experience you will get with features like live coding extensions and support for popular Java standard libraries. Integration with Kubernetes is one of the feature. It seamlessly integrates with Kubernetes and provides tools for developing, deploying, managing applications in Kubernetes environment. Quark supports a wide range of extensions that simplify the integration of various technologies, database, messaging system, and more. Just like Spring Boot, it has a wide range of support for various databases, messaging system, etc. Quarkus offers support for reactive programming with libraries with Word.x and Mutiny, making it suitable for building responsive and scalable applications. In summary, Quarkus is a compelling option for Java developers looking to build cloud native applications with performance and resource efficiency required for modern containerized environments. So GraalVM, let's look at what is GraalVM in short. GraalVM is a high performance embeddable polyglot virtual machine that is designed to run a variety of programming languages, including Java, JavaScript, Python, Ruby, R, and more. It is developed by Oracle and offered as an open source project. GraalVM is known for its unique ability to execute programs in multiple languages and provide seamless integration of these languages within a single runtime environment. So, a few features and components of GraalVM include polyglot execution. So, GraalVM allows different programming languages to be used within the same application, enabling interoperability and integration between them. High performance, it offers high performance execution for a range of languages, often outperforming traditional language runtimes. So this we are going to see how it also defeats normal Java virtual machine. AOT, ahead of time, JIT, we already know. We have seen this in JVM based virtual machines, and in fact even in JVM. So we'll move forward to embeddability. GraalVM can be embedded in various applications and used as a library to extend capabilities of the host program. GraalVM, so it's just a library, you can use it, and it's just plug and play. Native image generation is one of the feature where GraalVM's native image, it allows creation of standalone small fast starting native executables from Java application. This is particularly valuable for building lightweight microservices and serverless applications. So language support, as we have seen, it supports wide range of programming languages and provides extension for running and interacting with these languages. So compatibility, it is designed to be compatible with JVM and can run existing Java applications. So applications which are already running in JVM, they don't have to worry. They can be easily migrated. Okay. So GraalVM is popular in scenarios where you need to combine multiple programming languages, optimize their performances, reduce resource consumption, and create native binaries for your applications. So in native cloud, we have seen we have to pay as per your computation, right? As per resource consumption. So there, so keeping that in mind, is GraalVM is designed. It has gained attention in the context of microservice, serverless computing, and cloud native application development. Due to its capabilities, it makes building efficient and good for lightweight applications. So Spring Boot framework, while not exclusively dependent on GraalVM, Spring framework offers experimental support for GraalVM native images. This allows Spring-based applications to be compiled into native executables, improving startup times and resource efficiency. There are several frameworks uh, which are using GraalVM. So as we are seeing, Quarkus is Java framework designed for cloud native platform. We already know this. Quarkus makes this excellent choice of making use of this GraalVM. And next is Micronaut. Micronaut is another Java-based framework for building lightweight and efficient microservices. It again provides native image support through GraalVM to create standalone and fast starting applications. Spring framework, as we already know, it provides experimental support for GraalVM native images. Helidon is one of the framework again used for Java, and it is used again to create microservices. It supports GraalVM native images. It creates lightweight and cloud native services. Substrate VM is one of the framework. It's not framework itself, uh, uh, but it is used in combination with other frameworks to achieve AOT compilation. So the purpose of, as you can clearly see, the purpose here is to reduce the execution time, or you can say bootstrapping time required is they want to minimize. GraalVM Native Image Agent. This is a tool that helps developer to optimize Java application for GraalVM native image generation. It can be used with various Java frameworks to improve compatibility and performance of the resulting native executables. So these frameworks and tools highlight the versatility of GraalVM in enhancing the performance and resource efficiency of Java applications, especially in the context of cloud native and microservices development. Keeping that in mind, support for GraalVM may vary among the different versions of these frameworks. So it's essential to check documentation and updates for the most current information on their compatibility with GraalVM. Now we'll go to our first program. So we are going to use just like this is the link quarkus.io, which we are going to use to create our first application. Uh, so open this link on your browser, and just like Spring Boot, we are going to use Bootstrap project to start immediately coding and using this Quarkus framework. So first of all, to set up the environment, all we need is an IDE. It's going to take around 50, we are not even going to take 15 minutes. IDE, then you need to have JDK installed. So recommended is JDK 11 plus along with Java home path configured appropriately. Then you would need Apache Maven 3.9.5. And optionally, you can have this Quarkus CLI tool, which I have already opened here. This tool is very useful tool. I recommend using this tool. You can so it's very useful tool to create bootstrap projects for yourself, and you can use this link to install on your particular platform. I have already installed this tool on my machine, so I will proceed with the next step. Architecture we can skip for now. What we are going to do is we'll move to next step. Here we need to use this, we need to clone this repository. I have already cloned this repository on my local machine. Once you have done this cloning part, we now have bootstrapping project. So cloning repository part was done, and it can be done using CLI also. The CLI tool, if you have installed, you can use this Quarkus command. This Quarkus command should be if you have CLI tool installed, then only you can use this command to create a bootstrap project. So you can see this command Quarkus create app. Then you provide your artifact ID. I mean, there are options you can provide. Here they have provided this extension, and then optionally you can also use Gradle if you don't want to use Maven. We are going to use I'm using Maven, so I will be sticking to Maven for this video. And once you have this project, what you can do is you can import this project in your application. So we have imported that project in my IntelliJ IDE, and we are going to look at its folder structure. This command basically creates Maven structure, then resource exposed to /hello path, associated unit test, landing page that is accessible on localhost 8080 port after starting the application, and Docker file. So here in SRC, you will see there are 4 Docker files, and higher level you can see there is a JVM file, Docker file, and another Docker file is for native images. Okay, so we'll go through details in next video. Just for now, remember that these 4 Docker files are created by this Bootstrap project in Java. Let's look at pom.xml also. In this pom.xml, we'll find the import of, so Quarkus BOM is there, allowing you to omit the version of different Quarkus dependency. In addition, you can see Quarkus Maven plugin. So here you can see Quarkus Maven plugin. It is responsible for packaging the application and also providing the development mode. We'll look at greeting resource.java, which is our controller, which is also a simple REST point returning hello world for REST easy reactive, and also we have this another get method. This is the endpoint greetings and name. If we pass name as a path parameter, it will return back with some message along with that parameter. We are going to try. So now let's try to run this. So there are 2 ways you can run. So I can directly use Quarkus dev, or I can use Maven command, just like in Spring Boot. We can use Maven goal, or I can directly use Quarkus dev. Okay, since we are into dev environment, we are using Quarkus dev. Okay, I think I have made a spelling mistake. Okay, so it started running. So application is, let me say, n. So I'm running this. So listening to code, you can see the boot time. Let's open this. So you can see hello Ashish, it has printed, and if I simply say hello, it is going to print hello. Now let's look at one more thing. If I go back to the code and if I make some changes, okay, this is something I really liked about this. Let me add one word here. And I will come back and I will simply refresh. So you can see I don't have to restart. So these things are available in Spring Boot also with developer tools, but you will get these tools bundled with your basic framework of Quarkus. So yeah, this is about it. You can try it on your own. So yeah, one more thing I wanted to show is again, this was one blog. They have conducted. So this is like Spring Boot versus Quarkus blog, and they have done some benchmarking, and you can see so significantly. I mean, the build artifact time is it is more for Quarkus JVM, but if you look at startup time, it's very less. We have also seen in our project it takes very less time to start your container. So this warm up time is now getting warm up time of cloud native application is there. You will see the difference between Spring Boot and Quarkus JVM. Thanks for watching my video. If you are liking the content, then please like, share, and subscribe. Thanks for watching.